And we know vertical asymptotes are what makes the denominator 0. Horizontal or oblique happen when you divide things. One thing that we do need to look at on the graph, and we touched on when we were talking about domains, if something cancels, so x squared minus 9 factors into x plus 3, x minus 3. If you factor that, what happens to the x plus 3? It cancels out. So that does not create a vertical asymptote. That is what's called a hole in the graph. So a hole is like an open circle, and that happens whenever something cancels from the top and bottom. To find that, we take the thing that canceled. What makes x plus 3 equal 0? Negative 3. So that's the x value. To find the y value, you plug negative 3 into what's left. So negative 3 minus 3 is negative 6. So on this graph, it would have a hole or an open circle at negative 3, negative 6. Any questions about how we got that?
So where'd the both of the minus 3's come
The plus?
from? No.
Oh, right here.
Yeah.
Because our x value is negative 3, so I plugged that in for this side.
Oh, okay. Okay.
So on the handout I gave you at the top, it has all the steps that we need to go through. First thing, we will factor. That way we can see if anything cancels out and if that creates a hole in our graph. Then we can find our intercepts, x and y intercepts for our graph. We'll identify our vertical asymptotes, horizontal asymptotes, and then sketch our graph from there. So let's just start with a problem. First step is factor. X minus 1 I can't factor. What about x squared minus 4? Nothing cancels out, so I don't have any holes on this graph. Next thing we need are x and y intercepts. X-intercept is another word for a 0. Okay, it's just when your entire graph is equal to 0, or when the y is equal to 0. If you set this whole fraction equal to 0, if you were trying to solve, you would multiply over the bottom. What happens if you multiply 0 times anything? You get 0. So an x-intercept is really just when the numerator is 0. What makes the top of this fraction equal 0? 1. So I hit my x-axis at 1. How do you find a y-intercept?
Plug in 0.
Plug in 0 for your x's. So on the top, 0 minus 1 is negative 1. On the bottom, 0 times plus 2 and 0 minus 2. So I get a positive 1 for it. It does not matter if you put those into the original or the factored form. You get the same thing. So I've got my x and y intercepts. Now we need our asymptotes. Vertical asymptote. You have to give me the full equation because it is a line. What makes the denominator 0? So x equals negative 2, x equals positive 2.
Could you put that somewhere else?
Yes. And we draw asymptotes as dashed lines on our graph. Then we have to decide horizontal or oblique. And I talked to you about that Friday, and there's rules you can memorize, or you can really just think of it as dividing. those leading powers of x. If you take x divided by x squared, can you do it? So what do you get? It's a horizontal. If you can't divide them, it's y equals 0. So that's my x-axis. Remember, we did say a graph might cross the horizontal asymptote, so it won't ever cross over a vertical, but it could hit a horizontal or an oblique. All right. So we found all of our important information. We have all of our key components of the graph. Now, unfortunately, since we don't have graphing calculators, we just have to use test points to kind of figure out what the rest looks like. Options, the asymptotes are lines we're getting closer to as time goes on. Okay, it's got to get closer to both of these. So this first section of the graph, it's either going to be up here or down here. The only way I'm really going to know is if I plug in a number and see, is it above or below that horizontal asymptote? So you can use your calculator for this, and in fact I would recommend it. Just plug in a number. So I'm looking when my x is smaller than negative 2, so maybe if I put in -3. Okay, you can do it in the original or the factored. I think it might be just as easy to put it in the original. I don't really even care what I get out. I just care, is it going to be above or below my horizontal asymptote? Make sure if you're putting these in, you do parentheses for the numerator and denominator if you plug everything in at once. Or you can work it out. So you would get -4/5 or -0.8.
There's like a dot on
Oh, because you're actually on your graph. Okay, so that tells me when my x is -3, I'm getting out -4/5, so it's got to be down here. So this section of my graph, you need to make sure it's a curve getting closer to your asymptotes as time goes on. All right, this middle piece. I know it has to hit these points, right? You could certainly pick more points if you wanted, because I don't really know, is it like a parabola or is it coming down? So you could certainly plug in some more. If you put in a -1, so the top would be -2, -1 squared is 1, -4 is -3, so that would give me, -1 gives me a positive 2/3. Okay, can you tell what this is doing? You also know at the x -1, that had a multiplicity of 1. So should my graph bounce or go through there? It should go through. So I found this part's positive. I have to go through that point, so it's just going to keep going down. If you weren't sure, plug in more points. All right, now we just need to know this final section. What's it going to do? So give me a number we could plug in. What would I want to put in for my x? 3. So if I put in 3, 3 minus 1 is 2, 3 squared is 9, minus 4 is 5. So 3 gives me 2/5. So it's positive. So this section looks like that. Double check it on your graphing calculator. If you go to your y equals, plug in this original graph with parentheses around top and bottom and see if it matches what we have.
I don't, why is it 3 lines? I don't get it. Because your graph, you have 2 vertical asymptotes. Every time you get a vertical asymptote, it chops your graph. Okay.
So if I just have one, it makes 2 sections. Since there's 2, it's a section here, I have a section between them.
So then I see a graph in each. I just want to see it.
Your graph should exist on every side of a vertical asymptote. Think a vertical asymptote is just like cutting our graph in half. So if you have one vertical asymptote, you get 2 sections of the graph. If we have 2 vertical asymptotes, we should have 3 sections of our graph. So every time you have an asymptote, it's going to break apart our graph. What's wrong?
Where does the last one come from?
Well, we just know there has to be something over here. It didn't just stop at asymptotes.
There's no specific point.
We plugged in a 3 and we got a positive 2 fifths, so that told us it was above the horizontal asymptote.
So what's the point of this? Yeah, but if we got 2 fifths, why is it point at?
Because the x-axis.
Cause like on the.
Okay, yeah.
So I just put that to say, well, we're above that.
So you just did like kind of an estimate?
Mhm.
Okay.
So at this point, when I'm checking these, I'm looking, do you have all of this information correct? Did you plot all of that stuff on the graph? And then at that point, I'm just checking your shape. So your test points are really just so you know, am I above or below my horizontal asymptote at this point? I'm not checking if you plot those exactly. All right. This is all we are doing today. We are just practicing this over and over and over again. Do you guys have any questions on that one? Let's try another. All right, first step is factoring. How would the top factor? Okay, does anything cancel? No, so I don't have to worry about a hole in the graph. How do you find the x-intercept? Set the whole thing equal to 0. Does not matter if you use the factored or the original, you'll get the same answer. But every time, once you set it equal to 0, if you multiply over the bottom, you just get 0. So an x-intercept is really just what makes the top of that fraction equal 0. And what works? What's my x equal?
0.
0 is equal to x plus 1 times x minus 1. You set each of those tends to. So I hit the x-axis at -1 and positive. How do we find the y-intercept? Okay, does it matter if I do the original or my factored one? No. So if I put it in the original, 0 minus 1 is -1 over 0. Can we do that? So there is none. This graph does not touch the y-axis. Vertical asymptote. Vertical is x equals what makes the bottom 0. That's why we didn't have a y-intercept. The y-axis is my vertical asymptote. Horizontal or oblique. I told you you get that by dividing your highest powers of x. What happens if you do x squared divided by x? You have an x. If you still have an x, that means it's oblique. And how do we find the oblique? So my x goes here, x squared minus 1, or I could put x squared plus 0, x minus 1. Now remember, we're just looking for a line, y equals mx plus b, so we don't have to do the full long division, just enough. All right, so you start, divide your leading things. What is x squared divided by x? And then you multiply x times x. Okay, we subtract that off, so that's gone. And we just have 0x minus 1. 0x divided by x is just 0. Okay, this is all we need, so it's just y equals x. So that's a line, y-intercept is 0, slope of 1. Okay, this graph has one vertical asymptote. So how many pieces should I have on my graph? 2. One to the right and one to the left of that vertical asymptote. It has to be a function, so it has to pass the vertical end test. So that means this section, it's either up here or down here, right? But I do know if I'm going to hit this point, is it above or below that? It's above. So I don't even really need the test point here. I know I've got to be getting closer to my vertical. I have to hit this point, and then I have to be getting closer to my oblique. Okay, on the other side of my vertical, I have a point here, so I know I've got to be getting closer to both asymptotes. So this one looks something like that. Please try to make an effort to show that your lines are approaching your asymptotes. Sometimes it's kind of hard when everything's scrunched together on the graph, but it is getting closer and closer to that asymptote as time goes on. Any questions on that one? And if you weren't sure, you could always do test points to check yourself. All right. I want you guys to take a second on this one and see if you can list our information. It's already factored for you. See if you can list your intercepts and asymptotes. X-intercept is when the whole thing equals 0, which is really just when the top of your fraction equals 0. So you get -1. So we hit the x-axis at -1. Do we agree with that? Y-intercept, if you put in 0 for all of your x's, on the top we get 1, on the bottom we get 0 times 4, 1 over 0, we can't do that, so there is no y-intercept. Vertical asymptote, x equals, what makes the bottom 0? 0 and -4. So I have two vertical asymptotes, one at 0 and one at -4. Okay, horizontal or oblique. So we need to think about this. Since it was already factored, think about if you multiply it out, you would have x over x squared. Can you take x and divide it by x squared? No, so it's still an x on the bottom, so that's just y equals 0. All right, how many sections should this graph have? 3. One on the left and right and one in the middle. So now we have to have some test points. So if I put in maybe a -5. Okay, the top would be -4. On the bottom I get -5 times -1. So -4/5. All I really care about though is if I put in -5, is it above or below my horizontal asymptote? Below. So I don't even care if you plot that point exactly after you find it, as long as you draw your curve below that asymptote, getting closer to both. Okay, so we know it's underneath the horizontal asymptote, and as time goes on, it has to get closer to them.
So we don't have to put in like 0.8 as our point.
No, you can, like -5 point, -0.8.
We just have to show that it's like below the graph.
Yep. All right, in between. So let's try, I need to figure out what's happening here. So maybe if you put in a -2. So you get -1 over -2 times 2. So 1/4. So -2 is a positive number. So I know it's got to be coming down like this. Is it going to bounce off or keep going down? Keep going down, because we know what causes something to bounce. An even multiplicity. If it had been like an x plus 1 squared on the top, it would have bounced. So it's just going to go through that point. And then I need something here. So it has to be any positive number you want. You can plug in a 1, you can plug in a 2. We just want to know, is this above or below my horizontal asymptote? So if I put in 2, I get 3, 2 times 6. So that gives me 1/4. But again, all I really care about is it's positive, so it's above my horizontal asymptote. It's got to be getting closer to these as time goes on. If I wanted to make my graph better, could I put in more points? Yes, but I'm checking. Do you have x and y intercept and your asymptotes And then do you just correctly have your curve above or below your horizontal asymptote? That's what I'm looking for.
Where we're getting like the negative 2 and 2 and the 2 and the 6.
I'm just picking numbers, so like.
So I know you're picking like the 2 and like the negative 2, but where does the 6? So like 2 times 2 plus 4. Okay.
Anything else? Let's try another one. You have a question? Does it? Did you figure it out? Okay. You all right? Okay. So, for this one. Let's check by factoring. What would we do on the top? And that would leave us with x minus 1. The bottom, what would that factor into? Again, we're doing that just to see does anything cancel out. It also just speeds the process up as we're finding the rest of our information. Okay, nothing cancels. So if we keep going here, x-intercept. So x-intercept is asking where does your graph hit the x-axis. To find it, you plug in a 0 for y, which is really just saying when does the top of this fraction equal 0. So that would be at 0 and 1. So I hit my x-axis twice, 0 and 1. Y-intercept. How do we find that? Put in 0 for all of our x's. So you can do the original or the factored. You would get 0 divided by negative 12, which is 0. So we already have that. Vertical asymptote. X equals, what makes the bottom 0? Horizontal or oblique. To do that, we divide the leading powers. 3x squared divided by x squared, what happens? And you just get 3, so that's a horizontal, y equals 3.
Wait, how do you get the
We
horizontal one again?
divide the leading powers of x. So the highest on top was x squared. When you divide those, the x squared cancels. All right.
So, okay.
Mhm.
Okay, you're right.
Sure. So now we need to know, where does this graph go? So we need some test points. If I want to know what's happening over here, I need to know, is it above or below 3 for this graph? So plug in an x, something smaller than negative 4, so if you put in a negative 5. Use a calculator if you want to. You can put it in the original or the factored form. It does not matter. I just want to know, is our answer above or below? So what do you get when you plug in a negative 5?
Oh, that's not.
Negative 10.
I got 58.6.
58.6.
I have lots of different answers. Got 10. Either way, I guess. If They're both positive, right?
Yeah.
We're checking, are they bigger or smaller than 4? So this one does come out to be above. I think we might have had a calculator error there, but I don't care if you plot that point exactly, I just care, do you recognize that that curve is above? All right, in the middle, you might know what's happening, you might not. If you want, let's just plug in another point and see. If we put in a -2. If I put in -2, I get a -1.8. Can you tell what's happening on this one? This is coming down. We know it can't just be flat in between those. They both had a multiplicity of 1, so it's just going through. So it's like gonna hit both of those. Just be like a downward parabola thing in the center. Then we need a number bigger than 3. So if we put in a 4.
So you plug in like S. How do you know what numbers to plug in?
So
Are you going above the
I'm going
horizontal or
I'm plugging in numbers on each side of the vertical. So I have a vertical at 3, so I'm going to plug in a 4. And what I care about is, will my y value be above or below this horizontal one? When I put in 4, I got 4.5, which is above my horizontal. So then I know the last piece will look like that. All right, there's definitely a lot to these problems. It's not just a 30-second problem, but do you guys understand where I am getting my information right now? Okay. We are going to work on this some more tomorrow. So this is not just one and done. We will continue practicing that tomorrow. I have a handout for you. And I just want you to try the front. So it's 4 problems.
Oh, okay, me too.